right, good morning or good evening to everybody in virtual land. What we got today is we are in topic 8, block 7. We're on equations and inequalities. Our goals and objectives for today are to represent solutions for equations and inequalities on number lines, write real world problems corresponding to equations and inequalities, analyze situations involving linear relationships, and formulate linear equations and inequalities to solve problems. We're also going to apply the properties of operations as strategies to add, subtract, factor, and expand linear expressions and understand how rewriting an expression can shed light on a problem situation. And we're going to solve equations in the form of px plus q equals r and p times the quantity x plus q equals r, where p, q, and r are specific rational numbers. So today what we are working on is solving pages 1 through 11 in our guided practice. So my opening question for us today is that we see a series of 3 trucks on page 1. How are the trucks growing or changing with each new truck? What's happening there? Raise your hand if you know the answer. What's happening to those trucks? How are they growing?
Each time they have 3 more blocks.
Okay. So they get like 2 taller and then one, or like 2 taller on the left and then 1 taller on the right. Does that sound right? All right. So if we were looking at this, if we were to graph each one of these, truck 1 has how many blocks?
5.
And truck 2 has how many?
8.
And then truck 3 has.
11.
So if we were to graph this, would it be linear? Would it make a straight line? What do y'all think? If we were at, let's say this is 1, 2, and 3, and then we were going up, let's see, we'll go 1, 1 to 5 would be here. If we were kept going up, 6, 7, 8, that'd be 8. And then 9, 10, 11. Does that make a straight line? Would that make a straight line?
Can't see your
Well, that sucks. Wish I would have told me that a while ago. I'm just picking at you. That's okay. Way to help me out. So it will make a straight line right through there? Wouldn't that make a straight line? Yes, it would. Perfect. All right. So it is going to be linear then. So let's take a look at what we got. It says the process column. So basically, what that means is this is just saying what is the process that's taken place from truck 1 to the total squares in the truck. So when it says column, it's just meaning like the middle of these 3 columns. So this is 1, 2, and 3. Okay. So our process column is what takes place to figure out the number of squares in the truck. So right here it says truck number 1 is 3 times something plus 2. Well, if you think back to our little invaders, what do we always multiply by? Didn't it have something to do with the family? Didn't we multiply by the family number?
truck number?
Yeah, so more than likely it's going to be the truck number. So if we did 3 times 1, that equals what? All right, and 3 plus 2 is, isn't that what we said was there? All right, let's see what would happen here. If we did 3 times 2, we would get what? And 6 plus 2 is? All right, and is there 8 in this one? Haley doesn't have to be the only one that answers. She is correct. 8 is there. So looking at what's happening here, it looks like we're always multiplying by what?
The truck number.
The truck number. Good. So we're going to take 3 and multiply it by what number?
3.
And then 3 times 3 is?
9.
Plus 2.
11.
Are there 11 blocks in that truck? Yes, there are. All right, looking at question number 2, it says the pattern of the trucks can be described as follows. Truck number 1 has 1 row of 3. Truck number 2 has 2 rows of 3. This pattern continues where the number of rows with 3 squares equals the truck number. Also on top, each truck has exactly 2 squares. So write an algebraic rule that we could use to find the number of squares for any truck number. Use X for the truck number and Y for the number of squares. So what are we trying to find? I got to speed it up, guys.
Find the number of squares for any truck number.
Yes, that's going to be Y. And then they said there's 3 squares in each row, right? So we would do through what? I don't want to tell you the answer.
3.
Good. All right. Times what?
X.
Then what?
Plus 2.
And why are we adding 2?
Because of the windows.
Yeah. Each truck has 2 squares on the top, right? So that's going to work out perfect. Does anybody have a question about that one? All right, moving right along. Number 3. Mark the statements about the truck pattern that are true. Select all that apply. To Chandrik, what's one that's true?
The order pair 0, 2 is not an answer.
Okay. Because that wouldn't make a whole car, would it? It would just be like wheels and some windows. You wouldn't be able to have anything to sit on, would you? No. All right. Give me another one, Isabella.
To find the total number of squares in the 6th truck, we can substitute 6 for X in the equation Y equals 3.
That's true, because we could do 3 times 6 and do 18 plus 2, and that'd give us our answer. All right. Is there another one, Abigail?
Which one did she say? I don't want to say the exact same one.
She said to find the total number of squares in the 6 truck, we can substitute 6 in for X. And then Tashandrik said the ordered pair 0 to 2 is not an answer.
One of my answers were some ordered pairs that represent the relationship between the truck number and the number of squares needed to make the truck are 1, 5, 2, 8.
That does work. All right. And are there any answers on here? Any more answers?
There's one more.
There is one more. What's it going to be, Emma?
With 15 squares, we cannot make any truck above the 4th term in the pattern.
All right. And why is that?
Because 4 times 3 is 12, plus 2 is 15. Can't go any higher.
All right. So when we do that 12 plus 2, we're going to get 14. And then so if we go any higher, it's not going to be enough, is it? Go ahead, Sarah. Good job. All right. Looking at number 4. Roy Kia, it says, which equation tells you the value in the truck pattern that is created from 26 squares? So which one would you use to find that answer based off of what we've done?
Y equals 3 times 26 plus 2.
Great job. And why, how did you know that so fast? All right, who can help her out? What was our original equation? Wasn't it y equals 3 times x plus 2? And so Roikia knew automatically that 26 had to go in for what? What did 26 go in for?
X.
Our x. All right, you did great. Oh, what went wrong?
The answer is 26 equals 3x.
No, this would tell you how many squares were in it. Oh, I thought we were looking for the 26 truck. What do we do? What are we looking for? Who just said that? Isabella? Isabella, help us out. What did we do wrong? It said 26 squares in all, didn't it? So x wouldn't be 26. What's going to be 26?
The answer.
Yeah, the answer. So y is 26. So what one would we have to pick?
The third one, 26.
Yeah, that's right. And then to solve, we would subtract by 2, and then we would divide by 3 to figure out what it would be. Perfect. All right, so we got to make sure we pay real close attention to what it says, or you'll make a mistake like me. All right, number 5. If you had 100 squares, what is the largest truck number that you could represent? How would we find that answer? What could we do with our algebraic equation?
You could do like the truck number times 3 plus 2.
Okay, so
But you know it's not going to be 100.
yeah, because you got to add 2 to it, don't you? So do you want to just put these in and see what they would be?
And it wouldn't be 50, I don't think. Because
Let's see.
50 times 2 is 3, and you have to times it by 3.
I got you. Yeah, so that'd be 150. So that wouldn't work, would it? Then that next one was, we could do, is 3 times 25 plus 2. What would that equal?
That would be 70. I think it was 76.
77. All right. So this one could work. Let's see if 32 would work. What's 32 times 3? 96. And what's 96 plus 2?
98.
All right. So which one's going to be the biggest one?
32.
All right. Perfect. All right. Looking at this next one, let's see what we got. Would you read this one for us, please, to Chandrick?
Truck number 12 is the sequence. We have blank squares. Truck number blank is the sequence. We have 35 squares. According to the graph, the truck number blank is in the sequence. We'll have 17 squares.
All right, my man. Tell me how you're going to figure this out.
So A is 38 on the side graph. It tells us that 12 equals 38 squares.
Okay.
B is 11.
Because that one has the 35.
Yes, sir.
Okay.
And C is 5. Yeah, 5
And where'd you see that answer at?
on the graph.
Chris, does that make sense? Does that make sense to everybody? Give me a thumbs up if you feel confident in that question.
Yes, sir.
All right, good deal. So in this problem, all we had to do was what? What did Chandra say? All we needed to do was read the what?
Graph.
The graph. All right, Miss Emma, I want you to do the next problem. We start right here at the top.
Tim's classmate uses algebra tiles to model an equation. Tim correctly represents this equation and the steps he uses to solve it. Which set of directions best describes how Tim solved this problem?
All right, so how many x's do we have, Emma?
4.
All right, and then what do we have happening next?
-3.
And then we would say this is equal to how many are here?
15, I think.
Good. All right, so looking at our equations, what are the ones that it can't be? Or there's one that it cannot be. Which one is it not? It can't be that, can it?
Yeah.
All right, so we got 3 possible ones that it could be. So if we were to solve this, what's the first thing that you would do?
4 times -3.
Well, this is 4x minus 3. So what's the first step that you need to do so that you get 4x by itself? Like, how do you make minus 3 become 0 so that 4x is by itself? Yeah, we got to add 3. And that makes 0. So we're left with 4x equals 18. So looking at our stuff, can it be this one? Did they add 3?
No.
No, so it's out. So we only got 2 possible ones so far. They both, step 1 is looking right in both of these. So now we just got to see if step 2 is right. It says on both step 2s, divide both sides by 4. Is that what we're going to do? So that we get x by itself? Yep. So we just got to see how many times 4 will go into 18 and we'll have our answer. How many times does 4 go into 18? Help us out, somebody. 4 times 3 is 12. 4 times 4 is 16. Yeah, 4 times. When we subtract, we get a remainder of 2. So is this going to be 4 and 2 fourths, or would this be 4.2? If we put a decimal here, that means you got to have a 0. You bring that 0 down. How many times does 4 go into 20? 5 times. And so that means that our answer would be 4 and a half. So this is our correct answer. Now, for those of us that saw what I was doing the first time without using a decimal, when we subtracted, right here, this 2 is our remainder, which actually means it's our numerator. This is our denominator. 4 and 2 fourths is the same as saying 4 and a half, which is also this answer. Anybody got a question about this one? Give me a thumbs up or thumbs down. Use and nod. All right, looking at this problem, Miss Kaylee, I want you to read it for us, this next problem. Number 8.
Which equations are true when x equals -3? Select all that apply.
All right, so that means that we got to put in -3 for every one of these x's and see if it's true. All right, so I'm going to put them in there real quick. So I'm going to rewrite this as 5 times -3 minus 3 equals -18. All right, this one's -9 times -3 plus 7 equals 20. We have 10 minus 3 times -3 equals 1. -2/3 times -3 minus 3 equals 1. And -1/2 times -3 plus 5 equals 3.5. All right, so looking at this first one. Kaylee, what's 5 times -3? What's 5 times 3?
15.
All right, so we get -15 minus 3. That's the same sign. So -15 minus 3 is the same thing as saying -15 plus -3, which is negative what? If you're at -15 and you move 3 more units to the left, you would be at negative. Think about a number line. If you're at -15 and you move down 3 more places, you would be at negative what? 18. And -18, is it equal to -18? Yeah, makes it true. So that one works. All right, looking at that next one. Jemiah, -9 times -3. What's that going to be? Negative times a negative is a positive. So what's 9 times 3? Help her out, somebody. What's 9 times 3?
27.
Is 27 plus 7 going to equal 20?
No.
Nope.
No.
That one's gone. All right, Tashandrick, do that next one. We got 10 minus 3 times -3 equals -1. So what's the first thing that we do? Will we subtract or will we multiply first?
I think multiply.
That's right. We're going to multiply. So we're going to take -3 and times -3. So that is
9.
9. So this would be 10 plus 9. Would that equal 1? Nope. All right. Now we're getting into the hard ones. Haley, you ready? Remember that a negative times a negative is a positive. All right. So we're going to make this real simple. We're going to do 3 times 2 and then divide it by 3. What's 3 times 2, Haley? What's 6 divided by 3? All right. What's 2 minus 3? Talk louder.
-1.
Correct. Is -1 equal to -1? Yep. So that one works. All right, Emma, we got another one. All right, remember a negative times a negative is a positive. So we're going to take our 3, multiply it by 1, and then divide by 2. Emma, what's 3 times 1?
3.
What's 3 divided by 2? 1 and a. All right, so I got 1.5 plus 5. Is that going to equal 3.5? No. That would be 6.5, right? So that's out. Perfect. All right, number 9. Says which situations can be represented by the equation 3x plus 15 equals 288. Select all that apply. Sarah, do you know one of these?
No, I haven't answered that. I wasn't able to answer that yet.
That's okay. Layla, have you answered one?
That problem confused me.
All right. What about Lainey? Lainey, have you answered one of these?
I got Nate. Nate bought his children 3 identical phones totaling $288. Nate used a coupon for $15 off purchase. What is X in the discounted price of the phone?
Okay. Do y'all agree with that?
Yes, sir.
I do too. I think that works out perfect because you got 3 kids. You're taking $15 off. So basically what you're doing is you're subtracting 15 here. And so you get this, and then you have to divide it by 3 people. So I think that's going to work. I picked the wrong one. Nate bought his 3 children identical phones totaling 288. He used a coupon for 15. What did I put? Oh, yeah. If each charger was 15, that means you'd have to do 15 how many times? 3 times. And I'm glad y'all can read good. All right. What about that first one? Would it work, the one that I marked out? Nate buys a phone that costs $288. He puts $15 down towards his payment, and then he repays the remaining balance 3 times. Would that work?
Yes.
Yeah.
I got it.
Yeah, it would work. Because that's going to be the same thing, isn't it? All right, this one over here says Nate upgrades his phone. He makes 3 equal payments of 288. Cool. Is that what this is? That man's getting an iPhone Pro 12 or something. Not me. That ain't gonna work. That's some high dollar stuff. That's like them phones y'all get. Not me. I gotta eat. I'm just picking. All right. So next one. Nate bought his 3 children identical phones and chargers. He spent a total of 288. If each charger is $5, what is X, the cost of the phone? Would that work?
Yes.
Yeah, it could, because how many of these $5 did he get?
3.
3. And 3 times 5 is 15. So you're taking 288, subtracting 15, and then when you get that answer, you got to divide it by 3, right? So that should work. Did we get it right? That look good? Anybody got any questions? Laney gave me a thumbs up. I'm going to take it. That means that everybody else understands it also. All right, Mr. Eli, tell me how to do this one.
So you would multiply 0.25 by to the, or now you would subtract 2.5 to 0.25.
All right. So right here, this is negative 0.25 times x. And if we want, it says which scenario could be represented by the equation. So this is 2.5 minus 25 cents times X, and it's going to equal 75 cents. So look at this first one, Eli. It says Jonah needs $2.50 in quarters to wash and dry one load of laundry at a laundromat. If Jonah has 75 cents, how many additional quarters does Jonah need to complete one load of laundry? Would that work?
Yes, it would, because 250 would be how much money you would have, and then you would wait. Wait, no, it wouldn't work.
Yeah, I don't think it's going to work either. Let's try this next one. Jill eats a protein bar for lunch every day. The protein bar normally costs $2.50, but today the bars are discounted 25%. How many bars did Jill buy if she saved 75 cents? I don't think that's what's happening. Do y'all? All right, let's look at the next one. June walks 2.5 miles around the school track every day. One lap around the track is 1/4 of a mile. How many more laps does she need to walk if she has a 1/4 mile to go?
No.
And the last one says a snowplow needs to clear 2.5 miles of road. The snowplow can clear the road at a rate of 25 hundredths miles per minute. If the snowplow has already cleared 7,500 miles, how many more miles does the snowplow need to clear?
Yeah, I think that one's correct, because 2.5 miles, and then the snowplow clears 0.25 of a rate per minute, and and 0.75 is how much they already cleared.
All right, and so X would tell us how many more miles he's got to go.
Mm-hmm.
Uh-oh, it doesn't say that one's going to work. So that means one of these over here has to be correct. Who can help us?
The first one's correct.
You think the first one's right, Tashandra?
Yes, sir.
Tell us why.
See, I can't help you.
You said you can't help us? All right, so let's look at it. He needs $2.50 in quarters, all right, to wash and dry one load of laundry. He's already got 75 cents. So this is what's in his pocket. He's got 75 cents. All right, how many additional quarters does Jonah need to complete one load of laundry? Oh, I see what it's saying. So X represents the number of quarters. And so this question's asking how many more quarters does he need so that we can do $2.50 minus this. Is that what you're saying, Tashandra?
Yes, sir.
All right, so read that for us, Tashandra.
Jonah needs $2.50 in quarters to wash and dry one load of laundry at a laundry mat. If Jonah already has 0.75, how many more additional quarters does Jonah need to complete one load of laundry?
All right, so if we did that, how would we figure out how many more he needs? What would we have to do? Nobody knows? Wouldn't we just subtract $2.50 from 75 cents and then divide by 25 cents and they give us our answer? Wouldn't that work? Yes or no? Would that give us our answer, Eli?
I guess. I mean,
It's kind of just worded funny, huh?
yeah.
Yeah, that's one of them that's kind of worded weird. I think what it's trying to get us to see is that we're trying to find X. And so that's what it was trying to set us up for. I think the easiest way to solve this problem would be to actually solve it and then answer this. So I think what we should have done was take the problem like this and then go ahead and subtract our 2.5 from both sides. And so when we did that, the easiest thing to do is just take a calculator and do 75 cents minus $2.50. And so we get negative 175. And we set it equal to negative 0.25x. And then divide by that negative 25 cents, because this is the 25 cents that you need for your quarters. And so whenever you divide this, it's going to tell you how many quarters you need. So what we do is we take $1.75 and divide it by 25 cents. And so we would need 7 quarters. But I agree, that's just a funky worded problem. All right, let's look at number 11, see if it's any easier. All right, so looking at number 11, Destiny, read this one for us. I might have to sound like Destiny. A regular shaped pool has a perimeter of 128 feet and a length of 60 feet. What is the width, W, of the pool? Select the equation that represents this problem. So all the way around here is how many feet?
128.
Correct. And it says the length is 60. So the length on each side is 60. So what do we not know?
The width.
The width. So we don't know the width here, and we don't know the width here, but we do know to get perimeter, you add them all together, and it'll tell you what it is for the perimeter. So out of these, or without, don't even look at this. What could we do to find the perimeter? We know that the perimeter is 128. It wants us to find W. So we know that 128 is equal to how many links do we have?
260s.
Yeah, we got 260s. So that would be 2 times 60 plus how many widths do we have?
2 widths.
Yeah, we got 2 widths. So this is an equation we could set up to find out what W is. Is there one like that on there? And if there's not, is there another way we could write this? I see one that's like this. I'm just trying to see if y'all see it.
Number 4.
Yeah, that top one. All right. What's another one we could say? What could we do to this that looks familiar? What could we factor out of both of these? In other words, what's being multiplied by 60 and what's being multiplied by W?
2.
2. So we could factor this out by using the distributive property and rewrite this as 2 times 60 plus what?
W,
W. Is there one like that up there?
the first one.
Mm-hmm. Would the second one work?
No.
Nope. What about the bottom one?
No.
I don't think so either, because you'd be doing 60 times the width, and we don't know what the width is. This one says 2 plus the width times 60. Would that work?
No.
Nope. So let's check our answer. Make sure we're right. So we got it all. That looks perfect.